Welcome to Analyzing 33 Million Bike Trips with BigQuery. How's everyone enjoying NDC so far? Good? Is everyone still awake? I know it's late in the afternoon on the second day. Hopefully this talk will be fun. My name is Sara Robinson. You can find me on Twitter at srobtweets. I'm a developer advocate on the Google Cloud Platform team. So what that means is my job is to build demos to show other developers like yourselves what you can do with different Google Cloud Platform products. I focus on big data and machine learning. I also get to give talks at events like this and write online content like blog posts. And another part of my job is to pass the feedback I receive from all of you back to the product teams so they can use that to improve the product. So definitely come and find me after if you have any feedback on any Google Cloud products that you have used so far. I'm based in New York. This is my first time in Australia. I'm super excited to be here. It's been a lot of fun so far. I've been to Melbourne, Brisbane, and Sydney, obviously. So let's get started. So I moved to New York just about a year ago, so I haven't been there that long. And when I moved to New York, I started to notice all these City Bike stations everywhere. City Bike is the local bike share program in New York. And they really love their bike sharing in New York. There's stations all over the place. And obviously at certain times, some bikes are more in demand than others. So like in the summer right now, you can see City Bikes everywhere. When it's snowing, like in the picture in the middle, obviously the bikes are going to be less in demand. So as I noticed all these bike stations everywhere, all these questions came to my mind. Started wondering, like, how many bike stations are there in New York and surrounding boroughs? How many bikes are in circulation at a given time? Are there popular routes that people are riding, or are all the different routes pretty unique? And City Bike has a subscription system where you can pay an annual fee, and you get basically unlimited access to the bikes for a year. And so I wondered if how many trips were accounted for by subscribers versus people that didn't subscribe and maybe were just visiting New York. I wondered if men and women took the same bike routes. Tons of other questions came to my mind. But without any data, these are pretty tough questions to answer, right? Like, might be a tough interview question on a given day in New York. At 9 a.m., how many bikes are in circulation? You have to know, what's the weather out? Is it a weekend or a weekday? How many bike stations even are there? So difficult to answer these questions. So I was really excited to discover that City Bike makes all of their trip data publicly available. The system started in 2013, and you can download CSVs on every trip that's been taken with City Bike for about 4 years of data, which is pretty awesome. The data looks like this, which is a lot of text, just a giant CSV file. More specifically, one row of data. We get all this information. So we get the ID of the bike, and we get the start time and end time of the trip. We also get the start station, the end station, the latitude and longitude of both. And then if a person is a subscriber, we get data on their birth year and their gender. So lots of different demographic and bike data that we have access to here. And so I wondered how we can analyze it. And since I work on Google Cloud Platform, I chose to use BigQuery to do all sorts of analysis on my bike data. Has anyone here used BigQuery? Show of hands. Looks like a couple of people. BigQuery is our big data as a service platform on Google Cloud. It's fully managed. You upload your data to BigQuery, and you can query terabytes of data super, super fast. I'm going to do lots of live demos and show you how it works momentarily. All of your queries are written in familiar SQL. And you can write queries directly in the web UI and view the data in your table there. And then BigQuery also has a REST API. And we have a number of client libraries, including .NET, that you can use to interact with your data, upload data into BigQuery. If you're not familiar with SQL, BigQuery integrates with a number of third-party visualization tools. So if you use Tableau, if you're familiar with that, you can use Tableau to interact directly with your data in BigQuery and create some nice visualizations of it. A really cool thing about BigQuery is that you can share your data really easily. So BigQuery has a concept of data sets, and within a data set you can have multiple tables. So at a data set level, you can share your data set with a user by email, so you can share it with just one person on your team. You can share it with your entire team email alias, or you can even share it with any authenticated Google Cloud user, which is what we've done with the City Bike data and a lot of other data sets. And you can try it out for free. Everybody can run a terabyte of queries for free every month. So definitely recommend trying it out with our public data sets, and I'll show you how to do that throughout the presentation. And you also get 10 gigabytes of storage for free with BigQuery. So a couple steps to analyzing the bike data. First step was to import the data. I had CSV files for every month of bike data. Next step was to do all sorts of analysis on it. You saw all the different pieces of information we have for every individual trip. So lots of possibilities for how to analyze it. But sometimes we don't want to just see the data in the table output. We want to see visualizations of it. So I used a couple of different visualization tools to visualize what this bike data looks like in BigQuery. So the first step was importing it. And I chose to do this using the Node client library for BigQuery. You could do it with any number of the BigQuery client libraries. So what I did is I took all the CSV files and I put them in Google Cloud Storage, which is our object storage product. So to do that, all I needed to do in my Node script was just create a reference to Google Cloud Storage, and then get the files from my Google Cloud Storage bucket. And then I call this create BigQuery table method, passing it what I want my table to be called, and then the file with my CSV data for that table. So next step, all I need to do is tell it the schema of my bike data, and then I can create the table, passing it these options, and the final step is to just import that CSV file. So pretty straightforward. Then I had all this data available in BigQuery. My personal project, we've since moved it to the BigQuery public data project, so anybody can access it there. I chose to do it this way. There's a number of ways you can import data into BigQuery. You can do it via the web UI. If you just have 1 or 2 files, you can import your files directly in the web UI. You can use the REST API like I did. I did it with Node. You can do it with whichever language you'd like. Cloud Data Flow is our batch and stream processing service. And so if you want to do data processing in your pipeline, you can then output the data to BigQuery when you're done doing any sort of processing on it. And then finally, Firebase Analytics, which is Google's mobile backend platform for developers. So if you're building a mobile app, Firebase Analytics is a product that will track all sorts of event analytics in your application. And you can create an automatic export of your Firebase Analytics data into BigQuery if you want to write any custom queries on your mobile application's data. So now that we got it into BigQuery, the next step is to analyze it. So basically, I'm gonna go to a demo, and I'm going to show you all the steps I did to analyze the data, visualize it, just walk you through my data analysis process. So first things first is, it's a little squished here, but let me show you the table. So the table looks like this, and let me make that a little bit smaller. There we go. So the schema of our table looks like this. So this is all the data we have for a given trip. As you know from the talk title, there's 33 million trips, so we have 33 million rows in this table. It's 4.5 gigabytes, which is actually a very small table for BigQuery. As I mentioned before, it can handle lots and lots of data. And if we want to look at what an individual row in our table looks like, each row is a trip. So we get the trip duration, start time, stop time, start station ID, latitude, longitude, all sorts of things. And then as I mentioned before, if you're a subscriber, City Bike provides data on the birth year, so how old you are, and gender. So this first query I'm going to run is just going to count how many bikes were in the City Bike system by year. So we can see that in 2013, we have a little over 6,000 bikes. And then in 2016, nearly doubled. We have over 10,000 bikes in the system. And this data is nice to look at in the table output format. But one thing we might want to do, especially if we had more data points here, is we might want to visualize it. So I'm going to show you how you can do this using Data Studio. Data Studio is a visualization product provided by Google. So if I go over here, I'm going to risk it all and just create a new report from scratch and see if we're able to visualize this data. So this is a blank report, and I'm going to add a new data source. You can add a number of different data sources. I'm going to use BigQuery for this example. I'm going to write a custom query, and I'm going to go in here and just paste my query in. And it's using standard SQL. I'm going to connect it to my data set. And there we go. So these are the different columns in my data. I'm going to add it to my report. And now that it's in my report, I can create any type of visualization with it that I would like. There we go. So super fast. Now if we go into view mode, we have this nice interactive visualization of our data. And we can do things like order by year ascending, which would make more sense for this. And there we go. So that's how easy it is to visualize data in BigQuery using Data Studio. Throughout the presentation, I'm going to use different visualization tools, so you'll get an idea of all sorts of different ways you can visualize your data in BigQuery. This was Data Studio. So moving along to the next query. So next thing I wanted to look at was the number of trips by station to see like which stations were the most popular. And here we go. So we have a list of station names with latitude and longitude. Many of you probably haven't been to New York, so this probably doesn't mean too much to you. And I don't know about you, but I can't look at a latitude and longitude and visualize it on a map, although that would be cool. So what I did was in the BigQuery web UI, you can download the data as a CSV just by clicking this button. So I did that, and I used a visualization tool called Carto. It's a mapping visualization. And I was able to just upload the CSV as a data set and then create this heat map. So the darker red stations have more trips. I can click on a dot and see the name of the station and the number of trips. So as we can see in like Midtown, Lower Manhattan, most popular stations, Queens, Brooklyn, and Uptown have lesser used stations, but still, even in these stations, we have a lot of trips. They might also be newer stations as the system has expanded. So that's just one way to visualize geographic data in BigQuery. The next thing I wanted to look at was breaking things down by type of user. So I mentioned before that we have people that subscribe and then people that just visit. Maybe they're visiting New York and are using the bikes on a one-off basis. So if we run this query, we can see how these people are using the bikes. So we can see here that subscribers account for a much larger percentage of total trips than just customers, which is what they call people that are just using the bikes on a one-off basis. So of total trips, subscribers account for about 88% of them. And what's interesting here is that the average trip duration for subscribers is just around under 14 minutes, whereas for customers, it's 35 minutes, which makes sense because if you subscribe, you're probably using the bikes to commute, to get pretty fast from point A to point B, whereas if you're just visiting New York, you probably are using the bikes for sightseeing. So it makes sense that you'd be using them for a longer period of time. And then looking further into breaking things down by user type, I wanted to see if there was any popular routes. So I'm looking at user type, and then I'm using the concat method to get a list of routes. So I'm just concatenating the start station name with the end station name to see if there's any route trends in bike trips over the years. And what we find here is that even though the customers account for such a smaller percentage, they're only 12% of trips, they're taking the same routes over and over. And notice that the start station and end station here are the same. And this is right around Central Park, so a big touristy area. So tons of people are just picking the bikes up, dropping them off in the same place, riding around Central Park for a fairly long amount of time. They're using the bikes for over 50 minutes. And the first three are the same. People are just picking the bikes up, dropping them off in the same station, using them to ride around for a while. In the fourth row here, we see that this is a subscriber route, but it's only 5 minutes. So I'm guessing this is a popular commuter route in New York. Moving along to the next query, I wanted to look at routes by gender. So my initial thought was that if I broke it down by gender, it'd be basically the same. So let's see. This query is just taking the top 5 routes for women bikers. And I'm going to show you a query next of like how gender breaks down on total trips, but we'll start with this. So these are the top 5 most used routes by female bikers. If I then compare this to the top 5 routes by men, it's actually totally different, which I thought was really interesting. And I wanted a different way to visualize that, so I used Carto again. And what I'm able to do here is you can pass it a start and end, latitude and longitude, and then you can have it draw a line between the two and tell it if you want walking, biking, or driving routes. So I just use the biking routes between the two start and end stops for all of the destinations. So in purple, we see the female routes. In blue, we see the top 10 routes for males. And what's interesting here is that women are riding the bikes, looks like longer distances, and more over here in Brooklyn, whereas the men are riding that pretty concentrated area right here and using shorter routes. So I thought that was pretty interesting and a nice way to visualize different demographic trends by bikers. And then finally, I wanted to look at how the demographics of riders broke down by age and gender, because we have this data available in City Bike. And here we can see that 31 is the most common age of bikers. And we can see that men account for a much larger percentage of trips than women. And to visualize this, I used a tool called Exploratory, which is a desktop app. And you can integrate it directly with BigQuery, or you can just download a CSV and upload that to Exploratory and create a nice graph of your data. You can share them publicly. So this is the graph I created, and this indeed reflects the data you just saw. So we saw 31 was the most common age of riders, but we have riders ranging from as young as 16 all the way up to 90, so props to those people. So we've got riders, across the age spectrum. And the last type of bike query that I wanted to look at was, I wanted to see, City Bike gives us an ID for each bike, and I wanted to see which bike had the most number of trips since City Bike started in 2013. So I ran this query to just count the trips by bike ID, and we can see that lucky bike number 17526 had 5,594 trips since 2013, which is a lot of trips. It's kind of crazy. And what I wanted to do was visualize how this bike traveled through Manhattan over time. And what I did was I just ran a query to get the start time and latitude of all the trips that bike has taken. I won't show you the output of that query here because it's not very exciting in text format. But what I did was I imported this to Cardo, and they let you do animations based on one of the columns in your data. So I animated based on time. And so if I run this, we can see it starts in July of 2013. These are all the stations that the bike has visited. And you can see over here the month is changing. So you'll notice as it gets into our winter in New York, the bike will take a break for a minute there. It's going dark. It's pretty cold in New York in February. And then it gets a little bit more active. I won't play the whole visualization because it goes for about 2 minutes. But it's just interesting to see how it travels throughout the city and then sometimes makes its way across the Brooklyn Bridge and back over time. So I'll stop it for now. But yeah, it's just some interesting way to visualize how one particular bike has traveled throughout the system. I haven't gotten that bike yet, but it's a goal. I'll let you know if I do. So now I'm going to go back to the slides. So just to summarize, I showed you a couple different visualization tools, how we analyzed our data in BigQuery, and then visualized it using Cardo, Exploratory, and then Data Studio, which is a tool that's provided by Google. And some of you may be wondering, I'm guessing we have a lot of .NET developers in the house. Can I query my BigQuery datasets from my .NET app? And the answer is yes. We have a C# client library for you to do this. And I just wanted to show you how easy it is to use it from our C# library. So I'm going to switch on over here to code. And what I've got here is just a super simple .NET application that's going to run 3 of the queries from my application. So I'm just going to run it here. And we can see it's running, it's using the BigQuery public data set. And it's going to run trips by member type. There, it just finished. So it ran trips by member type, and we can see the output of our query here. We're also looking at routes by member type and top 5 routes by women. So if you've got a .NET app and want to interact with your BigQuery data directly from there, super easy to do using the C# client library. And there are the queries in C#. So if I go back to the slides. So the bike data is just one public data set that we have in BigQuery. I wanted to also show you a few of the other public data sets that are available in BigQuery. One of them is all of GitHub's code available in BigQuery. My teammate Felipe talked about this yesterday, so you may have seen his presentation on it. So about a year ago, we put all the public code on GitHub into BigQuery. It's a giant table. It's a little bit over 2 terabytes. and it's constantly updated. And here's just a Data Studio visualization of which languages account for most of the code on GitHub by bytes. So by bytes, C is 63% of the code. And if we look at it by repositories, JavaScript has the most, 14%. And since a lot of you are .NET developers, how many .NET developers in the room? Looks like the majority. I wanted to look at some C# code trends on GitHub. So if I hop on over here to the browser, back here, this is what the table looks like. So we have a couple different tables for the GitHub data. We have the contents table, which, as I mentioned before, is the contents of every single file in the head branch. And this is what one row of data looks like. These files are empty, but if we scroll over here, we can find some files with data. So this is a giant table. And you can join this with the files table, which has the ID. You can join on the ID field between files and contents. And this has every single file in the head branch on GitHub with the file path. And this table is a bit smaller, 346 gigabytes. So what we're going to find out is how many C# files are on GitHub. And I am going to uncheck use cache results so you know I'm not cheating. And we'll see that this is going to process 129 gigabytes. I'm going to run it. While it's running, any guesses? How many C# files on GitHub? You can just shout it out. Oh, it was too fast. Sorry. But the answer is 19 million, almost 20 million C# files on GitHub, which is a ton. It's pretty crazy. The next query I wanted to show you on the GitHub data is this one. This query is pretty simple. The next query I wanted to look at was what were the most popular NuGet packages, looking at all the public code on GitHub. So I'm going to run this. We're running some regular expressions here. This is going to query the entire 2.2 terabyte table. Oh, oops, I used the cache results. Sorry about that. But I meant to uncheck that before I ran it. Otherwise, it would take about 30 seconds. But these are the most popular packages. I don't see the BigQuery one on here yet, but hopefully soon. So I'm sure many of you recognize these different package names. But what this query did, which is pretty cool, is it looked at every single packages.config file on GitHub, of which there are a ton, as you can imagine. And we joined the files table with the contents table to then look for the ID of all of those packages and then just do a running count of them. So just an example of how you can use BigQuery to query lots and lots of data, since our byte tables were pretty small. So this is the query for most popular NuGet packages that I just ran. And the final section of my presentation, I wanted to end with one more thing. So what is a presentation without one more thing? What about Australian data? So I showed you a bunch of data from New York. Probably not as exciting to this audience, since I'm guessing a lot of you live in Sydney or somewhere else in Australia. So I wanted to show you some analysis on data specific to Australia. I couldn't find any bike share data for Sydney. If you know if a data set exists, please let me know, and I'll put it in BigQuery. So I couldn't find anything. It looks like the bike share program is relatively new here, but let me know if I'm wrong. So we have a couple of public data sets where I was able to find data specific to Australia. So one of these is a weather data set that we have in BigQuery. It's called the NOAA data set, and what this has is weather station data dating all the way back to 1929 for any station that was providing data. And what I did was I looked at all of the stations from Australia, and then I wanted to do some mapping to see if I could visualize any of the weather trends for Australia. And I created these maps, again, using Carto to do that. So I'm going to go over here to the browser. This is the output of that query. So let me actually show you what this data set looks like. So it's got, as I mentioned before, all the way from 1929, all the way up to 2017. It's updated frequently, and we have also a table of all the different stations. So each row in this table is weather data for one particular day at one station. So we have the station ID, year, month, day, temperature, and lots of other types of weather data, like visibility, maximum wind speed, whether it was foggy or not, precipitation, lots of different stuff. So I took all of the data on Australia, which was what this row provides. So I got the name of the weather station. This is just the output of that query that I showed you. Latitude, longitude by joining it with the stations table, and average temperature, rainfall, and wind speed. And I took that data and put it into Cardo. And just to show you what the editor part of this looks like is I can create what's called a choropleth map, which lets me filter based on a specific column in my data. So here I'm filtering on average rainfall. I could change this to filter on wind speed. And we can see that, actually, I don't know if there's any significant trends in windier regions. But if we look at temperature, this is in Fahrenheit. Sorry, all the data's in Fahrenheit. But this makes sense. As you go further north, the average temperature is going to be a little bit warmer. So back to our slides. One other type of data that I wanted to look at was data on Reddit comments for subreddits related to Australia. And my teammate Felipe, who's over there, thanks Felipe, maintains these tables of all Reddit comments in BigQuery. Every month there's a new table. So not just Australian subreddits, but all Reddit comments, which is really cool. Definitely recommend checking it out. So I wanted to look at a subset of Reddit comments from June where the subreddit had Australia in the name, which turned out to be the majority of the comments just came from the r/Australia subreddit. So I put those into a separate table. I got a subset of them by score, and I wanted to do some further analysis on it. So I decided I should add some ML to my big data to use a lot of buzzwords in one slide. And what I did was I did some natural language processing on those Reddit comments. So I took the table of Reddit comments and extracted the Australian ones, and then I sent them to our Cloud Natural Language API, which is an API that lets you get more data on your text. So you can extract entities, sentiment, and syntax from your text. I'm going to be talking about it in a lot more detail in the next session, also in this room. So if you want to hear more about it, stick around. So I took it, ran it through the Natural Language API, which is just a REST API, which gives me a JSON response of all this data. I put that in a separate BigQuery table and ran some analysis on that, and then used Data Studio to visualize the data. A little bit about the Natural Language API. So one of the methods is you can extract a lot of syntax information from text that you pass it. So this graph is called a dependency parse tree. I won't get into the details, but basically what it gives you is a lot of part of speech data on the text. So it tells you for each token or word in the text, is it a noun, a verb, an adjective, which words depend on other words in the sentence, and what's the role of each word in the sentence. So all this data, this is just a visualization of all the JSON we get back from the Natural Language API. So this is what the table looks like in BigQuery, and we can see I have this one column, which is just a giant JSON string of that response. So you might be wondering, how are we going to parse these if we're using SQL, because we're writing SQL to query our BigQuery data? And the answer is BigQuery has a feature called user-defined functions, which lets you write these custom JavaScript functions that you can do all sorts of string parsing on rows in your table. So we're going to run this function on all of our Reddit comment data to look at things like what adjectives are people using most in this subreddit. So I'm going to hop back over here to the browser, and I will show you the schema for my table. So I'm using the sentiment analysis from the Natural Language API. I'm getting the magnitude and the score. Tokens is that giant JSON string that I mentioned before. We have the subreddit, and then we have the comment text. And we've got about 27,000 comments in here. I'm not going to show you a preview because what could go wrong with showing Reddit comments on a giant screen? So I'll skip that part of it. But I will run this function, and I'm going to uncheck use cache results. So what we're doing here is kind of crazy. It's running this string parsing function, this JavaScript function here on every single Reddit comment in my table. And so essentially it's breaking it down by tokens, which is what the Natural Language API returns. In just over 16 seconds, it ran this on all of my comments. And we can see what the most common adjectives were here. Looks like mostly makes sense, nothing too surprising there. So we're looking at the most common adjectives. But in just over 16 seconds, it ran this custom function on all of the comments in my table, which is pretty amazing. One other function or query I wanted to run on the Reddit data was just looking at the most commonly used nouns in this data set. So we'll run a similar query, just looking for the nouns instead of the adjectives here. And again, the user-defined function looks similar to the one before. And there we go. So we can see some of the most common nouns used in the Australia subreddit in June. And I took this data and I put it into Data Studio, like I showed you at the beginning of the presentation. And I was able to create a visualization just to see how people were talking about different things on the Australia subreddit. If you want to do more analysis, the Natural Language API also returns sentiment. So you could look at, break down the subjects by sentiment. So when people are talking about, Australia or the government, are they talking about it positively or negatively? Another type of analysis you could do. So that's all I've got for today. If you're interested in checking out any of the different things I talked about, I've got all sorts of bit.ly links here. BigQuery has great documentation and getting started guides. cloud.google.com/BigQuery. If you want to use the C# client library, I created a bit.ly link to that. And then all of the New York bike data is publicly available here. I also wrote a blog post talking about the process I went through to get the data into BigQuery and to analyze it. The weather data is here. Again, all of these public data sets are under the same BigQuery project. So once you're authenticated with your cloud account, you can access them there. And then the Reddit data is in Felipe's public BigQuery project if you want to do any more sorts of in-depth analysis on that. So thank you all for coming. If you want to come up and ask questions after, I'm available. Happy to answer your questions. Thank you.